I'm not going to say my usual introduction. I'm going to see if you guys can do it for me because we all know how these introductions start. So go on then, introduce the video to me. Exactly. Good morning, year 5, and welcome to your lessons for today. I'm very sorry that this is where we are again, but you guys have done it a lot of times before. You know how it works. So you're familiar with the maths lessons. So we'll do the normal routines that we'd normally do for maths. And we'll see how you get on. Okay, we've had to skip the last 2 lessons for our previous unit because unfortunately you're going to be able to do reflection without being able to print all the sheets, and I can't guarantee that parents and caregivers have access to be able to print things off for you. So we'll leave those last 2 lessons, and then hopefully your teacher next year will come back to those last 2 lessons for you. So we're going to start on our new unit for this term, which I think is going to be the last unit that we do. So you will already have looked at kilometres yesterday. So today we're going to recap and have a look at kilometres and kilograms. Okay, so before we do anything, as always, we're going to start off and do our fluency questions, okay? So what I'd like to do is I would like to have a go at these questions. If you've got a timer to hand or an iPad or a watch, want to set yourself 5 minutes because we can do these in under 5 minutes now. So for questions A, C and E, I want you to have a go at doing them mentally, please. And if you can do B and D, you might need to do some working out for those questions, okay? So pause the video, give yourselves 5 minutes and see how you get on. All right then, let's see how you got on then. So the first one, 6 times 12, 72, easy peasy. B, we've got 6,483 plus 7,835 is 14,318. Then we have C, we have 61 add 30, just add the 10s together and add the 1 to 91. D, we've got our subtraction there. I'm hoping people have read the right operation for this because we do tend to make mistakes on these ones. So we've got 6,931. And dividing by 10, we know the number gets smaller. So if you imagine your decimal would have been here, we know if we do the trick where you move your decimal, so you're going to move it once to the left there. So it gets 10 times smaller. So it's 65.7. So well done if you got all of those correct. I assume most of you would have done because we've been smashing these out of the park this year. So what I would like you to do now is have a go at these fluency questions here. Have a go and see how you get on. It's been a long time since you've done these because you'd have missed out on a lot of this when you did this in year 4. So it's probably be the best part of a year and a half, nearly 2 years since you've looked at these. But again, set yourself a timer, pause the video and have a go. Okay, so this sort of recaps on some of the measurements that we actually did a few weeks ago where we looked at converting metres and centimetres. So the first one here in terms of metres, it's 3,000 metres. Okay, you have to multiply it by 1,000. And here if we look at our fractions, this should be easy peasy. You did your fractions in lockdown last time round. So we've got 1/5, 2/5, 3/5, 4/5, and of course we have a whole. And here, if we do the decimals, we know that 7 add 5 is 12. If we then turn that into a decimal, it's going to give us 1.2. Now we know that if 1/10 is 0.1, we know that 1/20th is then going to be 0.05. Okay, because it's technically then 10 times smaller than 0.1. Okay, so well done if you got all of those correct because it's been a while since we've done those. Okay. Let's move on to the more complicated part of our lesson today then. So here, as you always give me a round of applause, is my beautiful number line that I've drawn all on my own. On this number line, I'm going to plot my numbers of 1 to 10,000. Okay, that 10,000 there and those numbers represent grams. Okay, so these are the larger numbers. The numbers I'm now going to put on top are going to be our kilograms. So they're actually going to be 1,000 times smaller. So I wonder if you can think, well, what's 1,000 times smaller than 1,000? Yeah, okay, it's going to be 1. Okay, so 1 kilogram equals 1,000 grams. 2 kilograms equals 2,000 grams. I'm going to work our way up 3,000, 4, 4,000, and then work our way all the way up to 5, 6, 7, 8, 9, and 10. Okay, so we've got all of our grams along here in the bottom of 0 to 10,000, and our kilograms, which are 1,000 times smaller, going from 0 to 10 on top. Okay, I will have print screened that and sent that to you guys as an extra resource to help you with your lesson today so that you know that it's got to be 1,000 times bigger or it's going to be 1,000 times smaller. Okay, now it's being a little bit more complicated for you then. Let's break it down and look at the individual numbers between each of the kilograms. Okay, so if I've got 0 to 1,000 and I know that that's equivalent, so the same as 1 kilogram, I need to work out, well, what would halfway be? So you can either think, well, what's halfway between 0 and 1? So it's going to be a decimal. or what's going to be halfway between 0 and 1,000? What is it? Good, well done. Okay, it's going to be 500, which makes that 0.5. Okay. So if we now have a look at this then, we've now got a higher number. So we've gone beyond 10 kilograms now. So we know that 10 kilograms is the same as 10,000 kilograms. So we know we're getting bigger numbers here, okay? So we know that 15 kilograms is equivalent to 15,000 and 16 kilograms is equivalent to 16,000. Now I need to work out what's halfway between the two. So if I know that that's going to be 15.5, do you think you can tell me what's the middle number for the grams that I'm missing? Good, well done. Okay, that is going to be 15,500. Okay, now to help you, if you didn't understand that, let's use our part-whole model. So we've got the whole thing I'm looking for here, which is 15.5 kilograms. Now what throws us is that we've got kilograms and grams. So this is where you need to convert it in your head. So let's break it down into what we've got. We know we've got 15 kilograms and we know we've got 0.5 kilograms. But because I want to work out what that is in grams, I need to now convert these. So I know that 15 kilograms is the same as 15,000, so let's change that. We know that 0.5 kilograms is going to be half of 1,000. So half of 1,000 is 500. So if we add those together, absolutely correct, we've got 15,500 grams. Okay, so sometimes it's easier, which we've done this before, we've looked at fractions. If you've got a fraction and a whole number, you make them look the same. If you've got meters and centimeters, you make them the same unit of measurement. Same will apply to here as well. If you've got grams and kilograms, match it into one. It doesn't matter which one. Sometimes there'll be an easier method to go for depending on what the question's asking for you. So let's throw in some of our decimal work and really test your brain. So I've got 23.2 kilograms. I need to work out what that is in grams. Okay, so here's my number line. I'm going to use this to help me. So I know I'm going from 23 and I'm going to 23.5 because I'm going up in decimals here. So I need to think, well, what are the increments going to be? Now I know that we've all done this, and I know Miss Ashford's group, you've done this with her, and I know my group have done this as well. How do we work out the incremental jumps between our numbers? Good, well I know because I've got 5, we have to divide it by 5, there's going to be 5 lots in there, isn't there? Okay, so I'm going up in points and decimals, going 0.1, 2, 3, 4 and 5, okay? So like you just told me, I've got to work out, well, how do I now get from 23,000 to 23,500? Now you've already told me I've got to divide it by 5 because I have 5 increments that I'm jumping, so I'm really only going to be focused on 500, and I know that 5 lots of 100 are going to make 500, so I know these increments are going to go up in hundreds, okay? So now that I've got my number line, let's go back to the question. So I want to know the equivalent of 23.2 kilograms in grams. So if I find where 23.2 kilograms is, it's here, I can see the equivalent there, 23,200. Easy peasy? Exactly. So now that you know that, have a look at the toolkit that I've sent home with your worksheets as well to help you so you can see the numbers that you need. And I want you to pause the video and see if you can have a go at questions number 1 to 5. Okay, let's make it a little bit harder. So we need to convert something from meters, okay, into kilometers, but I've now thrown in fractions here. So not only are we doing our decimals and conversion of units, but I'm throwing in some fractions today, so I'm really frying your brain today. So let's use a number line because it's easy when we do that. So we've got kilometers again, and we've got meters, okay? If I start at 0 and I've got 1, because I've only got half a kilometre here, so I need to work out what half of that is, and the maximum we're going to is 1, okay? If I now work that out in meters, okay, 1 kilometre, same as 1,000 metres, like 1 kilogram, so kilo is 1,000, 1 kilogram is the same as 1,000 grams, okay, so same rule applies here, it's either 1,000 times bigger or 1,000 times smaller, okay. So if I know I've got 1,000 metres, I need to find half a kilometre, I know that's going to be half of 1,000. What's half of 1,000? 500, exactly, there you go, first answer done. So 500 metres is the same, so equivalent to half of a kilometre. So let's apply the same concept then, but let's just do it the other way around, but with kilograms and grams. You know that kilo is 1,000, so you know that 1 lot of that is the same as 1,000 grams, okay? If we're doing this in fifths, we know that our denominator tells us how many equal parts we've got. So we know that these are going to be going up in fifths, okay? That much is easy enough. So now we need to work out, well, what 2/5 of 1,000 is. So going back to the same question I asked you before, how am I going to work out what each one of these increments is worth? If I divided these by 5, what am I going to do down here? I'm going to divide it by 5. 1,000 divided by 5 is 200, okay? So know that each one of these is going to be worth 200. So if we get to the 2/5 one, we know that's going to be 200, 400, 600. Well, I'm only looking for 2/5, and I can see there that my answer is 400. Okay, so all you need to do is make sure you use a number line and divide the numbers. Easy peasy. Okay, now this looks more complicated than I think some of you think it looks. Okay, I want you to pause the video and just look very closely at that fraction and what do you notice? Can we simplify it so it's even easier? Okay, that's the same as a half. If I doubled 34, I'd end up with 68. So if I'm looking for half a kilogram, we know that half a kilogram, okay, there's got to be 1,000 grams in 1 kilogram. So we know that half of 1,000 is 500. Easy peasy, okay? All you have to do is convert that fraction to make it easier for you. Now, this one requires 2 steps, okay? Because as you can see here, we've got meters and we've got kilometers. And it wants the answer in kilometers. So if it wants the answer in kilometers, what are we going to make sure these are both measured in? Good, we need to convert that one to kilometers because that way it's the same, okay? So let's plot it on a number line, okay? So we know we've got 1,000 meters. We know that each one of those here, okay, is going to be from 0 to 1. We've got 1,000 in 1 kilometer. So each one of these are going to now be 0.1 because we've got 10 increments. So it's got to go up in tenths. And we know that tenths is the same as 0.1, okay? So if we're looking for 400 meters, we can see that 400 meters is the same as 0.4. We know that as 7 tenths, we know that's 7 lots of tens, okay? So we count 7, 1, 2, 3, 4, 5, 6, 7. That's going to be the same as 0.7. Add them together, what's my answer? Exactly, 1.1. So we've got 1,000 meters there and 0.1 kilometers added together. Easy peasy. Now that you know that and you've had a bit of a practice with those ones, we can pause the video, see if you can have a go at questions 6 and 7. All right then, last one. So onions cost 9p per 100 grams. Okay, and Jack's going to buy 2.1 kilograms of onions. And we need to know, well, how much money does Jack spend? So let's think about what we know. We know the onions cost 9p. We know that's per 100 grams. We know that Jack buys 2.1 kilograms of onions. Now, does anyone spot the problem already? Yeah, good. Grams and kilograms here. So I need to do some conversion, okay, some converting here of my numbers so I know that they're going to be the same unit of measurement, okay? So let's convert it all into grams because it's easy to do it all into grams and then convert it back to kilograms at the end. So we know 2.1 kilograms. We know that this represents 2,000, okay, because it's 1,000 kilograms, and this represents 10, and we know that tenths of 1,000 is 100. So that's 2,100 grams, okay? We now need to divide that by 100 grams, okay, to work out, okay, how much money Jack's going to spend. We know that's going to be 21, okay? So in order to now work out what he needs to do, we know that each one costs 9p. So if we do 21 multiplied by 9, that's going to tell us how much money he's going to spend. Now, I'll be honest with you, I'm not sure I know what 21 times 9 is, okay? So there's 2 ways of doing this. You could do 20 times 9, so you know it's going to be 2 lots of 90, which is 180, and I could add 9, because that will give me the extra 1. Or you could multiply it by 10, so you'd have 21 times by 10, and then we could take away the 21, okay? And we looked a lot at that when we did our converting of numbers. When was it? Easter holidays, I think it was. So we can do 21 times 10, we know that's 210. But because we were doing it multiplied by 9, we need to take that 21 off because we need 1 less than that. Okay, so we could do 210, take that away. It's 189. Same as doing 20 times 9, add the extra 9. So if he's going to spend 189p, we now need to convert that into pounds and pence. We know that we've got 2 lots of pennies there, so it's going to be 89 pence. And we've got £1. So it's going to be £1 and 89 pence. Okay? Now, Mo cycles 300 metres in 1 minute. Okay, we need to work out how long it takes them to cycle 6 kilometres. Okay, so we know 6 kilometres is 6,000 metres. Okay, if 1 minute's 300 metres, then that means that 200 metres. Okay, if we multiplied 300 by 2 to give us 2 minutes, that's going to give us 600. Okay, to get from 600 to 6,000. I know I can multiply that by 20. So whatever I do to this side, I have to do to this side. So if I multiplied 1 by 20, it's going to give me 20 minutes. Okay? So have a go at going through questions 8 to 10. If you're stuck on the last few questions, go back and watch those last 2 examples again. Okay, just because I know the video will cut me off in a minute. So go back and have a look at them and use the toolkit to help you. Okay, and we'll see how you get on. And then we'll pick this back up on Tuesday, where we'll then have a look at looking at kilograms and kilometres again. All right, good luck, year 5.